right, ladies and gents, good morning, good afternoon, good evening, wherever you are, or wherever you are. Okay, so if everything went according to plan, you already wrote the test for elements, compounds, and mixture, so hopefully all went there. And now we're starting a new, not just a new topic, a whole new module, okay? So we're leaving that chemistry behind and we're moving on to physics, okay? This is a big unit. It's going to take us until at least October or something like that. And this is all about energy, forces, and motion, okay? So if you continue to do science in grade 10 up to matric, this topic will be under what we call mechanics, okay? We start with energy, we'll move on to pretty quickly to forces, we'll spend quite a lot of time on forces, and at the end, we'll pull it all together if motion, okay? This is what we call physics. What we've done until now is chemistry, now we're in the domain of physics, which is a part of science, okay? So the first thing to do, energy, what is actually energy, okay? I won't really be able to ask yourself, what is energy? Okay? I'm not really going to be able to explain it completely because, what I can say a scientific definition of energy. It's not a definition, but kind of is, energy is the ability to do work. But then what is exactly work? Okay? So, rather than define energy, what we're going to do is talk about different kinds of energy. Okay? Right, so yeah, I've written behind me. Normally in class, I will ask you what kind of energy you know, and actually a lot of you do know a lot of energy. So it's a little bit going to be difficult just me talking without you, you just listening. But whilst I'm talking now, maybe just pause me for a second, and without looking at the board, okay, and try and come up with at least, let's say, 5 different types of energy you know. Okay? All right, pause me, do that, and then we'll carry on. Okay, cool. So let's start with kinetic energy. Kinetic energy is energy that an object has if it's moving. If I'm moving now, I've got kinetic energy. Okay, I've got kinetic energy. Heat energy, when something is hot, let's say I'm holding a hot cup of tea, you can feel that heat. That's heat energy. Okay, sometimes we call it thermal. Now you already know that when that water is hot, that means that the molecules there are really moving very fast. So in a way, if you think about it, heat energy is a type of kinetic energy, isn't it? Heat is just when I feel it, but really if you're looking on the molecular level, you're just saying that it has more kinetic energy. Think about it. Right, light energy. Light, okay, I don't need to explain to you what light is a form of energy, okay? So we can use light as a source of energy. For example, plants, okay, need to have light that comes from the sun or even from a bulb to grow. So it's a form of energy. Sound is a type of energy. Okay, you probably maybe saw in the movie some opera singing, oh, and shatters a glass. So sound carries energy. You can do something simpler. You can just put the bass on, put some kind of really deep bass, and then you will hear like things shaking. Okay, maybe the windows vibrating. Maybe you can have a little, a nice little experiment is to take a balloon and stretch it over something, put some rice on it, and it will start dancing if you have very low sound, okay? So sound is a type of energy. Right, on the other hand, and I will talk about why I've separated them, okay? We've got something called gravitational potential energy. If I lift an object up, it gains gravitational potential energy. And it's important to say potential energy. I'll explain why in a minute, okay? So that pen right now has gravitational potential energy. I can't see it. Okay, I can't see it. It looks like a normal pen. It just looks like it when it was just sitting here. But when it's high, it has gravitational potential energy. How do I know it has gravitational potential energy? Because when I let go, it starts moving. If it's moving, it gained kinetic energy. So now it has kinetic energy. Where did the energy come from? From nowhere? No. It was here in the form of gravitational potential energy. And that's why I can explain now why we call it potential energy. Because when he's at the top there, he only has a potential energy. We can't see it. It's a type of stored energy. Okay? We can only see it when it comes down. So all these guys will be called stored energy. I probably should have done it at the end, but never mind. all these guys on the right, I tend to call them energy in action. Okay? Because we can see the object moving right now. We can see the energy. We can feel the energy of a hot cup of tea. We can hear the energy of a violin. Okay? These guys are stored energy. So we spoke about one kind of stored energy, gravitational potential energy. Any object that is lifted up has gravitational potential energy. I'm just going to grab a couple of things to show you. Okay, so another kind of stored energy is what a spring has, or a rubber band. And we call that stored energy elastic potential energy. So if I stretch that, now it has energy. Okay, how do I know it has energy? Okay, if I let go, it starts moving. So it got kinetic energy. So before that, it had some kind of stored energy. What do we call it? Elastic potential energy. Okay, another kind of stored energy is the magnet. Okay, so right now, these two magnets, okay, they have, well, I need to separate them. I need to use force. That means they have energy. When I put them there, they have magnetic potential energy. We call it magnetic potential energy. It's a form of stored energy. How do I know that they have energy? If I let go, they pull each other out. Suddenly I had kinetic energy. So magnets have magnetic potential energy. Another, probably the most common stored energy is electric potential energy. So in the wires, in the national grid, the big wires, we have electricity. Okay? And electricity is a form of energy. Electric potential energy. It's a stored energy. We can use that electric energy to have light, to have sound coming from our speakers. As you can hear me now, you're converting, or your devices convert electric energy into sound and to light. And we can use it for heat. So we can have electric ovens that converts the electric energy into heat. Okay? Magnetic, electric, chemical. Okay? What is chemical energy? This paper, okay, has chemical potential energy. What does it mean that it has chemical potential energy? What will happen if I light it up? Okay? Let's just do that. Okay, right. Can never just talk about things. You've got to do that. Okay? So I've got paper, and I'm claiming it has chemical potential energy. You know, if it has stored energy, then there should be a way of releasing that energy. That's what we're going to do. Okay? Right? So by lighting it up, okay, fire, okay, we're basically converting the chemical energy into heat energy and light energy. But the energy was there before. It was in the form of chemical energy. Okay? It's in the form of the bonds between the molecules. This is a compound, a mixture of compounds. There's lots of bonds, chemical bonds. And when I create this chemical reaction, that energy is released in the form of heat. Okay, right. So that was chemical potential energy. Another very famous example of chemical potential energy is inside us. Where do we get our energy from? From food, of course. Okay? So when we eat food, in the digestion process, and then into more really in respiration, okay, we convert. Okay? You might have learned about respiration. If you haven't, you will learn later this year or maybe next year. But respiration is the process where you convert sugar, small units of food, into energy. Okay? So food is another example of chemical potential energy. So what I'd like you to do now is just copy that down, and then I'm going to do another video. I'm not sure if that's going to be in this lesson or the next one. So just copy the notes behind me, and then we'll move on.